Hello everyone. So I'm going to go through the steps to create that setup and then the eventual KUKA KRL file that we'll be hopefully using successfully in the lab this week. So the first thing to do, if you haven't already, is copy these 4 files that I've shown here from the shared SIM655 directory. Okay, place those in an area where in your own OneDrive or USB stick or whatever. Okay, so that's those 4 files that they need to be in place. The next thing that needs to be in place is your environment variable. So here I've provided this resource 1980 underscore update. Now, one thing is you don't need to write anything now because this update library contains the robot, the gripper, and the cube pen tool. So you can just use it as is from my, again, from the shared directory. So here we would go for browse directory, come up here to the SIM655, then we go to KUKA lab, resource update, resource 1980 update, and then make sure that you're selecting this resource directory. Okay, so always the final directory in this path here has to be a directory called resource. And the last thing, of course, that you have to do is add a backslash. Okay, and then you click OK, OK, and OK. Okay, and then we'll start up NX. Okay, then we go and open to our OneDrive area here. Let's open up the KUKA lab file. Okay, so that opens up the KUKA lab assembly, cabinet, sheet holder, and cube with pen, right? So the cabinet, sheet holder, and a cube with pen. Okay, so those are all ready to go. So the first thing we're going to do is create a new robot machining setup. So we click on New, then we select the Manufacturing tab. I'm still looking into why Manufacturing tab doesn't appear for some people. Hopefully we'll be able to resolve that soon. So within the Manufacturing tab, click on General Setup. Then you'll notice that it's created this file, Seneca KUKA Lab, and then it's appended this underscore setup underscore 1 to the part name. So it's a new file we're creating. It's based on the Seneca KUKA Lab, so it's going to use the geometry that we've just opened, and then it's going to put it in the same directory as the part file. So I click OK. Okay, so I'm here. So the next thing I want to do then is I want to position the work coordinate system correctly so that it's in the right spot so I can add the robot the most efficiently. So the way that I'm going to do that, what I've done in this file is I have left some the robot dummy geometry here. So this is the robot geometry in the original step file that I got from KUKA, but I've left it in here so that I can properly position the WCS. Okay, so I'm going to do that. The next thing I'm going to do is here I'm going to blank out the cabinet so that we can get the origin in the right spot. Okay, so here then I go to the tools, then here in utilities I click on more. I'm going to orient the WCS. I'm going to click on the point dialog, select between 2 points, make sure that I have arc ellipse center, this method chosen for both of the points, and then I go in here, I choose this for point 1, and then the diagonally opposite hole for point 2, and there it creates a point right in the middle, 50% between the two. That's fine. Let's go over here, and I want the x-axis to point through this front face. So in the face opposite to where the power is coming into the robot, I want that x-axis pointing in the opposite direction. Okay, so there it is. Okay, now it's not showing the WCS. Let's display it, and there you can see. Okay, so that's fixed. So what I want to do is go back to the view. I will turn off that robot, and I will turn the cabinet back on. Okay, so now I go back to the operation navigator. Then I go to the machine tool view. So here in generic machine, I want to change this to our robot. So I double click on it. I check on retrieve from the library. I want a robot. I want the KR3R540, which is right here. Double click on that. Now to positioning, so I'm going to use the part mount junction. I'm going to click on the CSYS dialog, and one more time the point dialog here. Oh, sorry, no, I'm sorry. I just click on WCS. Sorry. Okay, so I have our WCS was already carefully positioned. So I click OK. And one more time. Okay, so it brings in the robot and positions it as we have. So there you go. The next thing we're going to do is retrieve devices. That's the gripper. And it's in the head class. So double click here. And it's actually the first one in the list. So click OK. And there you can see it's been added. And then the last thing is to add the cube pen, robotic end ball mill. Click OK. Then in this lib reference, we're searching for a tool that has the word cube in it. So we click on, type in the word cube and hit return. And here it is here. And we just click OK. Okay, that's underwhelming here. There's no cube pen shown, but if we click OK, and then we come back to our operation navigator, we do a right click below, expand all. You'll see the cube pen is here, and if I click on it, you'll see that it's in place. Okay, so with that done, the next step is then to add our operation. Let's insert an operation of type mill contour. And then we come down here to contour text. Click on that. It's going to be using the cube pen. We're going to use a workpiece, and the method is going to be nil finish. And here we'll call it engrave, let's say. Okay, so we click OK to that. Okay, so here in the main, we've got our cube pen. Now we have this drafting text. Now we need to place that. So let's, for now, click OK. All right, so you see we have this engrave operation, but we need a WCS in order to position it correctly. So let's go actually into the geometry view. And let's edit the workpiece. We will specify the part. That will be this sheet here. We'll click OK. We'll also specify the blank, which is just the top of the sheet as well. We'll click OK. Let's also move this MCS. Oh, sorry, not here. Here, point dialog. We'll choose this time an endpoint. And here we'll click on this edge. Okay, and we'll position the machining coordinate system there. Click OK twice. And then here again, we have to move the WCS, because that's what we need to position the text correctly. So again, we choose Orient WCS. We're going to specify that same endpoint, like so. And here we're going to have to rotate slightly. Again, so the machining coordinate system and the work coordinate system are coincident. So there they are. Now, to create this text, what we do is we come over to the Geometry tab. Then in this Geometry group here, we click on the drop-down under Point, and we click on Note. Okay, so I'm going to create this text. I'm going to make it a bit bigger. Let's make it, say, 20 millimeters. And click Close. And then let's create it like here. And then close. Okay, now we have to be a bit careful because this model here is flat, whereas the one in the lab has a curve to it. So we have to be careful that we haven't. In fact, let's select this note. And let's edit that so that it's 90 degrees. And if we can, let's click on specify location and maybe click over like up here, just so we avoid the curved area of this sheet. And that looks pretty good. So let's click close there. Okay, so that's that. Let's go back to now our engrave operation. So we double click that to continue editing it. So now we're in a position to specify the drafting text. Click here, and again, sometimes it's tricky to pick it, but there we go, we've picked it. Okay, in the geometry, we've already picked. We can edit And so we're here. If we look at the part, so there's the part, and we've also specified the blank, which is again that top face. So that's all ready to go. The tool axis here is very weird, but let's give this a go. So we're going to do dynamic. And what it does when you do that is it now brings in this dynamic, this coordinate system here. So what we're going to do is bring this here. Now, the tricky thing is to sort of ignore what you see here. Okay, and let's bring this around to here, I believe. And then rotate this like 20 degrees. Okay, so we have the z-axis pointing about 20 degrees off the normal. Now, the reason why I do this is because if the pen is pointing straight down onto the paper or onto the surface, then that creates a very stiff interface here, and the pen could easily be broken. So if we have it off at an angle, then there's a bit of flexibility there. So it makes it a bit easier on the pen. Okay, so hopefully that will work. Now, let's see, feeds and speeds. I think everything else is fine, except for this last one where we switch to motion output type line. Okay, let's give this a go. So we'll generate this. And if I come around here, yes. So I can tell that it's okay by looking at the shape of this tool path. So that you notice that the tool path has been angled in this way. So that means that's how the tool will be oriented during the writing. So that's good. Okay, so let's take a look at what this is going to look like. So I go to the Home tab up here, and let's simulate the machine. Okay, so let's maybe back out here. Oh yeah, and make sure you've before you click on Simulate Machine, click on the operation that you want to simulate. Okay, and let's play this. Okay, so then kind of as we expected, we get this silly wraparound thing. Let's just continue. But I'm getting the right tool orientation. That's what I'm looking for here. And this is all good, except for the fact that it's a silly orientation. Okay, let's stop and then finish that. Okay, now so the next thing then is to produce these robot rules. So just to remind you, we go to this ribbon options. It's a drop down right at the far right side here. We click on that down arrow and then check off this robot machining group here. And when you do that, then you get this robot machining group that appears. Okay, so the first thing is to go to robot control. Okay, let's start with the poses here. So let's go to here and like so, and maybe we'll rotate that the 20 degrees like so, and maybe I'll move this up somewhere like this, maybe a bit higher up like so. Okay, let's create a new one, call it pose 1, and let's use this current values. Let's create a new pose, call it pose 2, and let's move this over, oops, move this over to the other side. Okay, and that looks about right. Okay, let's use the current values of that. Then if we scroll down here a bit, let's get out of this. So down here we have to specify the configuration. Let's use the current configuration here. And then tool orientation, let's just use fixed relative to part. Okay, and then if we use the current vector, then that should be fine. Okay, so those are the we have two poses. We have our configuration and tool orientation. So we click OK. Let's just edit that to make sure. Configuration, two poses, use the two poses, and then the tool orientation. So that looks good. Again, just make sure the operation is highlighted and click Apply and say yes. And that looks good. Okay, let's go to Simulate Machine once again. And hopefully this time we should have a good robot program. So that's looking good. Now, one thing you sort of have to be careful of is this A4 axis. So let's just finish this. Okay, that looks good. Let's go right back to the beginning. So we'll reset the machine. And we can step through this. So let's play the next block. Okay, so you'll notice here, you can tell the A4 position here by the KUKA. Sort of, it's an easy thing to check. And then if we click it again, so notice that the KUKA, sometimes with these poses and so forth, the A4 can get really messed up. So you have to just make sure that the A4 doesn't suddenly go 180 degrees off, but it looks good. Okay, so this looks good. Okay, and just as it finishes this 5, and it's going to go to the final pose, so let's stop, play the next block, Okay, again, I'm looking for a sudden movement. Okay, that looks good. Okay, so then let's take that. Okay, let's save the setup file. And now the last step then is to go to the post-process step. Now, this is weird. I'm not sure why it's doing this, but okay, so we've got UGII tempter will be used to, okay, let's click OK. And so we're going to use the KUKA KRL, that's good. The name is going to be engrave.src. And these other things about, well, we'll definitely want warnings and listing the output. We're going to see that too. So let's click OK. Okay, and I already have a test run of this, so let's click OK for the overwrite. Now, there's a warning. And the warning is this operation with no moves. And I haven't traced to why this is the case. But the other thing I see here is the output file name, and it's not been placed where I've got my files. So let's go to this directory. So the first thing is it's got this UGII tempter. So if I go here and edit the system variables, and if I come down here, UGII tempter is ctemp logs. So let's click here and click here. So here, C temp logs, and then the rest of this was Seneca Kuka Lab. Sorry, Seneca Kuka Lab setup 1, Kuka KRL, and then there's an engraved.src. So if I edit this one, I should see basically this listing here from this point down. Okay, so it's this file then that we will want to use to drive the robot. Okay, all right, thanks for listening.